Listening practice test, Meteors. Meteors are small particles of matter in the solar system that are only directly observable when they fall into the Earth's atmosphere. A meteorite is a meteor that reaches the surface of the Earth without being vaporized. Meteorites are particularly valuable geologic specimens because they represent samples of planetary bodies, usually asteroids, which we have not yet obtained through either manned or unmanned space missions. Neither is it likely that samples of the bodies will be available by any other means than fortuitous falls for at least a generation. Thus, as a scientific resource, meteorites provide us with some of our first glimpses of the diverse array of planetary material scattered throughout our inner solar system. The oldest meteorite specimens are remnants of the very first geologic processes to occur in our solar system 4.6 billion years ago. The origin of the solar system should not be confused with the origin of the universe, commonly known as the Big Bang, which occurred at least 9 billion years ago and possibly as long as 20 billion years. Our solar system formed when a cloud of interstellar dust and gas collapsed. Because of the interstellar cloud that had been slowly spinning, the result was a nearly flat rotating disk, which we refer to as a solar nebula. Much of the dust and gas in the disk moved to the center of the nebula, where it fed a growing protostar, which eventually became our sun. The dust and gas remaining in the nebula was incorporated into primary planetary material. Initially, nebular dust stuck together or accreted to form small, loosely bound dust balls. In some regions of the solar nebula, these dust balls encountered violent high-temperature events and were melted, forming molten silicate and metal droplets like lava. Henry Clifton Sorby, a geologist of the 1800s and one of the first to examine these droplets with a microscope, described them as having once looked like fiery rain. Because the high-temperature events were brief, the molten droplets cooled quickly in the nebula and formed millimeter-sized spears of rocks called chondrules. Meteorites obtaining these objects are called chondrites. Sometimes the temperature rose so high in the solar system that dust began to evaporate, leaving behind refractory residues. At other times, the temperatures became so low that new dust condensed from the nebular gas, like snow from the air. Over time, chondrules, evaporative residues, and condensates collided with each other and accreted to form nebular sediments and eventually larger bodies called planetesimals, a few to several tens of kilometers in diameter. Our most primitive meteorite specimens are samples of these complex yet primitive mixtures of nebular or pre-planetary material. In many cases, these meteorites are so primitive they contain traces of interstellar dust which survive thermal processing in the solar nebula. These small planetary bodies, from which primitive meteorites come, form throughout a large portion of the inner solar system. Within these vast distances, material was apparently distributed unevenly and affected by different amounts of thermal processing. Thus, meteoritic parent bodies produced in different regions of the solar nebula had slightly different chemical and structural properties. The three principal groups of primitive chondrites representing these variations are the carbonaceous chondrites, astatite chondrites, and unequilibrated ordinary chondrites.